Alright, time to do some more calculus here. The definition for the derivative that we're going to be using in these problems is the f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over really what's underneath here. This is just like the slope formula again. It's x plus h minus x. The x's cancel there, and you end up with just that h on the bottom. So you have that from your notes. I just don't want you to ever lose sight of the fact that this is just the slope formula for these 2 points, the f of x plus a little bit of a wiggle over to the side minus f of x over the difference, the run, which is just that h, the difference between them. All right. In the last homework assignment, we were using that other definition of the derivative at a point. Which looks like that. So they're really the same thing. It's two different ways of defining how like that one point is sliding, whether you define it like as a completely separate point at C, or whether you define like the difference between them and then let it collapse down to 0. Alright, so today we're using this one, but I don't think we need it in 7 and 8. So 7 and 8, I want to write the equation for a tangent line at x equals 3. Well, to write the equation for a line, I need two things. I need point and I need slope. So, and then I can write it in point-slope form, which is our preferred way of doing it. So in f of number 7, it says f of 3 equals -1. That means that, right? There's point 3 comma -1. And f prime of 3 equals 5. Well, f prime of 3 equals 5. That's the same as saying the slope at this point is 5. So that's like saying the m is 5. I'm going to put that in parentheses. We're not going to think a whole lot about that m. We're going to try to graduate from that and think more in terms of this kind of notation. Okay, so what's the equation for this line? Y minus y minus -1 is y plus 1 is equal to the slope 5 times x minus 3. I really would prefer if you just leave it like this. If you can't help yourself and you need to do some algebra there, it's not necessarily a bad thing, but there's a reason why we like point-slope form. And I'll tell you what it is right now. No reason for me not to. I can't remember if I talked about this in any of the notes yet or not. The reason we prefer point-slope form, it's not just because we're lazy and it's less work. It's because in this form here, the information that's coded in this is the information that's important to us. If you're writing the equation for a line that is the tangent line to a curve at a particular point, then the things you want to know are what's the slope and what was the point you were talking about. 3, -1. I can see it right here. Now, if you do some algebra here and you say, oh, okay, let's see, y equals 5x, and then I'm going to distribute the 5, -15, and then -1. I mean, you can do that. That's the equation for the same line in mx plus b form, but you have lost the information about the point where it's tangent. You have lost that. And we want that. So we prefer this. It's not because we're being lazy. Okay, so 8, same thing. My point is -2, 3, and my slope, f prime of -2, is -4. So y minus y equals slope times x minus x. Boom. That is not hard to do. All right. Number 9. Use definition 3.2.1. That's this. To find the define f prime of x and then find the tangent line at that point. Okay, so let's do it. Remember, we're not being lazy here. F prime of x, this is the beginning of the sentence, equals, that's the first thing you should write down. H approaches 0. I've got f of x plus h. So I'm plugging x plus h into 2x squared. minus f of x all over h. Got to write that down there. 2x squared. I'm just distributing the two. I know how to do algebra. You know how to do algebra. Come on now. We're all adults here. You know how to do algebra. So whatever makes you happy in terms of writing out steps or not. So here, like, I feel pretty confident about in this next step. I feel confident that I can rewrite, that I can factor this out, and like I don't feel like I have to write it out with those gone, and then also have like another step where I factor out the h. Right? See what I mean? So the h's cancel, and then I also feel confident here that I can cancel the h's out and plug in the 0 for that h in one step and get 4x. I don't really think that you could skip more than what I did here. I think that's pretty streamlined. So that's my opinion. You could argue with me about it if you want. So f prime of x is equal to 4x. That's the derivative function, right? What's the derivative of 2x squared? 4x. If f of x is 2x squared, then f prime of x is 4x. Okay, now we can make a little tangent line at the point where a equals 1. So that would be the point 1, comma 2, if I plug that 1 into the original function. And then f prime of 1 is 4. And then I'm just back to like doing number 7 and 8 right in the equation for a tangent line. Y minus y equals m times our slope. I don't want to say m. It's like for babies. All right. Cool. F prime of x equal to the limit as h approaches 0. What do we got here in number 10? 1 over x squared. So that's going to be 1 over x plus h squared minus 1 over x squared over h. Now, okay, we're back to that situation now where you can either do the common denominator thing or you can multiply through by that common factor to get rid of denominators. Either way, you should end up with a next step that looks like x squared minus x plus h squared over x squared times x plus h squared times h. I don't know why I put a little dot there. That's weird. I mean, you know, if things are next to each other, that implies multiplication. All right. Doesn't make it different, but... so I guess I need to do a little bit of algebra here on the top, right? So... again, depending on what you're comfortable with, you might want to write one more step out than what I'm going to write out here. I know that the x squared and the leading x squared here are going to cancel out. And then I know I've foiled this out like a bazillion times. You could just write this up here if you want to kind of keep track of things. So I know those are going to cancel out. I'm going to be very careful. I'm not going to make that rookie mistake where you forget to distribute the minus sign through here. So it's going to be minus 2xh minus h squared over x squared. I'm not going to distribute any of this stuff because I'd have to FOIL that out first anyway, because I know that I want things in factored form. That's better. Okay, so now I think I need to factor out, I'm going to factor out, well, it doesn't matter, h or negative h. I'd like to get that negative sign out there. You don't have to. And then have 2x plus h. You could have left it h out here and negative 2x minus h. That works. X squared times x plus h squared. That looks like a negative sign. Sorry, there's not a negative sign there. Times h. Okay, now the h's cancel, and I think that I can, in one step, cancel the h's and plug 0 in for h. So on the top, I've got negative 2x. Once you plug this in, that number, that is the first place where you don't have to write this anymore. As soon as you plug that number in, you've resolved your 0 over 0 problem. That's when you get to stop writing the limit. And then if that's 0, then that's just x squared times x squared. So if that looks familiar, like number, I don't know what it was from yesterday, 11? No, 12. And that's because it's basically the same problem, same function. Not basically, it is the same function. Okay, so that means if you want to know what the slope of 1 over x squared is at any point x, that's it. So that in the language of calculus, we say the derivative of 1 over x squared is negative 2 over x cubed. Or f prime of x is equal to negative 2 over x cubed. All right, so what's the point they want us to make a line at? Negative 1, comma, that would be 1 when I plug that in. And when I plug negative 1 in here, the negative remains negative when I cubed it, so the slope is 2. So my tangent line is y minus 1 equal to 2 times x plus 1. There's the tangent line. Cool. I mean, come on, this is pretty cool, don't you think? 9. What am I doing that for? We already did 9. 11. What are we going up to? 11 up to 14. Okay. So we're getting better at these, right? Limit as age approaches 0. Better. I didn't mean really better there. Really, like faster, I guess. X plus h cubed minus x cubed over h. Algebra. Pascal's triangle. Like it? Oh yeah. It's awesome. Because I can just do this. And then minus x cubed. Probably did this example, this exact one in the notes. So those cancel out. I think that I can write the next step and factor out an h at the same time. So that's 3x squared. Going to drop an h off of each one of those because it's out here now. Plus h squared. And oh dear, that's all off the screen. Sorry, I just noticed that. So there's all the stuff I was doing. And then going to plug in 0. It's going to knock that stuff out, so I get 3x squared. So the derivative of x cubed is 3x squared. All right. And then we want a tangent line at 0. So plug in 0 into x cubed, you get 0. And you get a slope of 0. So the line that goes through 0, 0 and has a slope of 0 is called the x-axis, or the line y equals 0. Alrighty. Number 12. Got my function is 2x cubed plus 1. So 2, it's the x plus h takes the place of the x, 2x cubed plus 1. Minus f of x is 2x cubed plus 1. H. You know what happens if you make like a little algebra mistake? The whole thing goes horribly wrong. That's what happens. So you have to be careful. Like for example, you want to make sure that that distributes and this 1 cancels out. If it doesn't, then you're going to have problems trying to factor your h out. All right, so I guess I got to do this game again. So let's see, that's 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed, right? It's the same as this thing, just with a 2 distributed through it, minus 2x cubed minus 1. Oh, I forgot the plus 1 here. That's the mistake I'm talking about. That's like catastrophic error. But the good news is you can usually catch those mistakes, because if you feel like there's a thing that needs to cancel out and it's not canceling out, then look back, maybe you just made a little error. So 2x cubed, those cancel out, and the plus 1 and the minus 1 cancel out. So what do we got here? We got, I'm going to factor out an h. That's not too much to ask. 6x squared plus 6xh plus 2h squared, all that stuff's gone, over h. And I think we're ready to rock and roll now, and by rock and roll I mean plug in 0 for h, and that knocks out those, that canceled, so 6x squared. So in the language of calculus, you could say that if f of x is equal to 2x cubed plus 1, then f prime of x is equal to 6x squared. They want a tangent line at where x equals -1. That'd be the point -1, and then let's see if I plug in 2x cubed, it would be -2 plus 1, that's -1. And my slope, in other words, f prime of -1, is 6. So y minus -1 equals 6 times x minus -1. There's my tangent line. Didn't put a box around that one. 13. All right, square roots. Going to have to multiply by some conjugates here. I think I showed you how to do that in the notes, didn't I? Basically 3 tricks. There's like the polynomial, Pascal's triangle kind of ones, and then there's the get a common denominator kind of ones, or multiply through like the ones like 10, like this. And then there's the ones with square roots where you have to multiply by the conjugate. And then you can, if you have a really mean math teacher, that math teacher can make up problems that are like combinations of those things. I think we're going to see a little bit of that in the book. Might see that on the quiz. Just saying. H. Okay, so I need to multiply by the conjugate of this. So I'm going to just put parentheses around that. Why am I going to do that? Because it works. That's why. And if I multiply by that on the top, do that on the bottom also. Alright, so where does that leave me? Well, multiplying by the conjugate, it's easy to do that because this is just like the difference of 2 squares now. So when I multiply this minus this times this plus this, I just have this squared, which is x plus h plus 1, just removes the square root sign, minus this squared. And be careful to put that in parentheses, because it's that whole quantity squared. And that's over h times this mess. Don't get all like I'm going to distribute this now. Remember, we want to leave things in factored form. That is better for us. So don't try to do anything with that. Alright, so let's see what we got on the top. I got some canceling is going to happen here. Limit as h approaches 0. X minus x. The h is still there. And 1 minus 1, so just an h. And then on the bottom, Oh, let's just cancel those out and leave a 1 behind there. So now I've got the square root of x plus h plus 1 plus the square root of x plus 1. Okay, now I can plug the 0 in. So when I plug 0 in, I have the square root of x plus 1 plus the square root of x plus 1. According to the rules of algebra, that's 2 square roots of x plus 1. Okay, so we did it. That's the derivative. If you got the function f of x equals the square root of x plus 1, the derivative of that is 1 over 2 times the square root of x plus 1. You want to find a tangent line where x is equal to 8? Why not? So plugging 8 into the function, we get 3, and f prime of 8 is equal to, let's see, plug 8 in here, the square root of 8 is 3, times 2 is 6, so 1/6. Alright, so y minus 3 equals 1/6 times x minus 8. I love point slope form, so easy. Alright, 14 looks kind of similar. A little more practice with this conjugate business. So we have the square root of 2 times x plus h plus 1. Parentheses management is of much importance here. Being neat is too. Alright, I guess, dang it, I probably shouldn't have written that there because I need a little room to write out my conjugate thing that I'm going to multiply by. If you're wondering here, you know, Mr. McGrath, I think I could get away with skipping this step and just going to what happens after you multiply by the conjugate. I think that I'm okay with that, but you can't skip writing this out, and you can't skip writing the what you get after you multiply by the conjugate. You can streamline things. Just be careful. Don't try to be a hero. And that's okay. I'm not. I want to make sure you understand the difference between showing your work and expressing mathematical truth in a clear way. Do you know the difference? Hope so. I don't want you to show work just for the sake of showing it. I want you to express true, clear mathematical ideas. If you can express them with a little bit more conciseness, a little more concisely, concision, is that a word? I don't know. Okay, multiply those, square root signs go away, plus 1 minus parentheses management, and then I got this whole thing. I'm not going to try to do anything with this, distribute the h, because I like it in factored form. You know what's coming, right? Stuff's going to cancel. It's going to get nice, or nicer. Okay, so let's see. On the top, I got 2x minus 2x cancels. I've got plus 1 minus 1 cancels. So the only thing left is 2 times h. Still h is in there, so I've got to keep writing that. 2h. At the bottom I got my h here, and then I got 2 of these things. Oh, no, I have the whole thing. Sorry, I haven't plugged in the h equals 0, so I cannot combine them yet, but it looks like they're the same thing. If h was 0, then these things would be the same, right? That kind of always works that way, doesn't it? And then last step, h's cancel. I get a 2 on the top, and then I have 2 of these square roots of 2x plus 1. So that's not wrong, but I could cancel those 2's out and just simplify it to 1 over the square root of 2x plus 1. All right, there's my derivative. What's the derivative of the square root of 2x plus 1? Oh, thanks for asking. The derivative, or f prime of x, for that function is 1 over the square root of 2x plus 1. Want a tangent line at x equals 4? Sure. Plug 4 into this, 4 into the original function, we get 3. And then f prime of 4, excuse me, slope at 4. To find that, you plug 4 into the derivative. That's 1 over 3. And then you throw down your tangent line. Y minus, jeez, I'm trying to go too fast. Y minus 3 equals slope x minus 4. There it is. I don't know why I feel like I have to put boxes around the tangent lines and not the derivatives. Whatever. All right, we got 2 more little problems here. The end of this, right? I have to do like 27 and 28. This is another case where if you looked at the directions for this and you're like, I have no idea what's going on here. Once you see what's going on, these are actually really easy. So if you see, like after I do 27A, you're like, oh, I think I get it now, then please pause and try the other ones. They're super fast. I'm going to write over here on the side the 2 definitions that we have so far. Oh, you want to know a secret? There's my phone ringing. Hold on for 1 second. Be right back. Hey, I'm in the middle of making a video. Can I call you back? Hey, I'm coming back. Here I come. Back. So f prime of c equals oh, I was about to tell you a secret. So the secret is the first question on your 3132 quiz is going to be, or I guess the first task, it's not really a question, is going to be for you to write these 2 definitions of the derivative. Don't tell anyone. It's a secret. So there's the 2. What we're trying to do in 27 and 28 is look at some limits and recognize that they are versions of this, or like articulations of these for a particular function and a particular value of x. So the first one, they did this little delta x thing. The first thing I'm going to do here is I'm not going to write delta x's. I'm going to write those as h's instead. When we did our whole, like, oh, here's a function, and here's like this point x, and here's this little distance h, and here's x plus h, and we'll slide this in by letting it, that whole thing from the notes, you could call that little h, it's like a delta x, like a little change in x. I don't use that notation. I know they do that a little bit in the book. So I'm going to rewrite that with all the delta x's replaced with h's, because I think it's going to look a little bit more familiar to us. Okay, so what's up with this? This, I think, with the h approaching 0, clearly this is an example of this one, not this one. So what's the function, and what is the x value? So if you look at the x plus h, here's a 1 plus h. I think pretty clearly the function here, or the point, is it's at x equals 1. And what is the function? What's happening to x plus h? It's under a square root sign. So the function is the square root of x. So if I asked you if, like, we did this the other way around, these problems are kind of backwards in a way, right? This is like if I said in numbers 7 through 14, if I gave you this and said, hey, do the definition of the derivative thing with this, and then plug 1 in for x, you'd end up with this, right? So we're just trying to work backwards and unravel what what the function is and what the x value. Now here they've got these little x sub 1s here. Whatever. I mean, it's just a name. I'm just going to write them as x's. Maybe it's slightly less confusing. Now, you don't have to do this. What we're trying to do here is match this up. Which one of these does this match up to? Definitely this one. So let's see. What is the x value? It looks like it's 3. What's the function? Oh, it's x squared. So same thing, if I asked you to write out, using this definition, the derivative at x equals 3, this is what you would come up with. All right, so if you feel better about those now, pause here and try number 28. What's the limit? Oh, you know, I should have said here too, we never really talked about this number here. That needs to be the right number. It needs to be the thing that you get when you plug this number into that, right? It's the f of c, or the f of x rather. So do you get, if you take the square root of 1, do you get 1? Yeah, that's the right number. So we should check that too, just to make sure we're good. All right, so here, pi plus h plus 1. Ooh, that's weird. Plus 1? So if you're thinking about what's going on there, because the definition has to be that, it must have actually been minus negative 1, right? Because that's not negotiable. That's always minus. All right, so let's see. It looks like the x value is pi, and that x plus h is getting plugged into cosine function. And then I just have to check to see, is the cosine of pi equal to negative 1? Yes. Cops are coming for me. Can you hear that out the window? So let's see, x to the 7th minus 1 over x minus 1. Looks like my x value is 1. And my function f of x is x to the 7th. Right. So just check, is it, when I plug x in here, 1 to the 7th, is that equal to 1? Yep. There it is.